Today we'll look at inverse graphs and equations. Let's actually start with the machine metaphor of functions. Functions are often thought of as a machine that takes an input value and produces an output value. For example, if the point 3, 5 is on the graph of y equals f of x, then we know that when we put a 3 into the machine, a 5 comes out. So our input is a 3. And our output from the function is a 5. Those also correspond to our x and y values. This allows us to imagine another machine which always does the opposite of what f does. We call this the inverse of f of x, and we use the inverse notation. Notice this is an f with a little -1 after it. It is not actually an exponent. It's just notation used to indicate an inverse. We read it as f inverse. Another way of thinking of this is whatever the function f does, f inverse will undo that. So for example, if we take a 3 and input it into f, we get a 5. If we want to undo that, we start with a 5, we put it into f inverse, and the output is a 3. So it essentially undoes the function. Let's take a look at how this could work. So given the domain range map for y equals f of x, let's draw a domain range map for the inverse. In the inverse, we'll start with the y values, -3, -2, 2, and 3. And the inverse should return the x value that the original function started with. -1, 0, 1, 2, 8. So notice we essentially just switched our x and y values. Now we need to map each of these correctly. In our original function, if we trace 1, we'll see that 1 gave us an output of -3. In our inverse, -3 should return a 1. So we'll do a line going from the -3 to the 1. You can similarly fill in the other lines. So we go from -2 to +2. We go from 2 to 2 different numbers. So you'll notice the original had -1 and 0, both giving 2 as a y value. So our 2 should give both -1 and 0 in return. And then 3 returns an 8. F of x is a function. We can see that because for any x value, there is only one y value, but its inverse is not a function. Specifically because if we look at the 2, for one input, there are 2 different possible outputs. If we go back to f, we also notice that f is not a one-to-one function. This gives us another way to identify that. In order to be a one-to-one function, f of x is a function and its inverse is a function. If both of those are true, it is a one-to-one function. Now we can also use this concept on a graph. So given the sketch of a relation, we can use a table of values to create a sketch of its inverse. Let's create a table of values for the original f of x, and we'll just pick some key points. I would go with these, and let's put these on a little table of values with x and y. So we have -5, -6, -2, 3, 2, 4, and 5, -2. So each of these is an x value that then gives us an output of a y value. To create our inverse, we just need to switch our x and y values. We start with the y value, and we're trying to undo to go back to what was the original input, our x value. So we would have, for example, -6 with an output of -5, and we're just switching x and y values. We go -6, we go positive 3, negative 2. We go 4, 2, and we go negative 2, 5. Now we can plot these points and connect them and see what our new graph looks like. So we've got a point at negative 6, negative 5. That is going to connect to 3, negative 2. And I'm going to connect them as we go, just so we can kind of keep the shape of the graph preserved. Then we go to 4, 2. And then we go to negative 2, 5. And this is the inverse of our graph. Notice that the original graph is a function, the inverse is not a function. That's okay. So in general, to graph an inverse, we want to find key points on the original graph. We interchange our x and y values of those key points to get points on the new inverse graph, and then we plot the inverse. Let's do one example of that where we have to generate the graph ourselves. So we'll sketch the graph g of x is equal to the absolute value of x plus 2, and then we'll also sketch the inverse. Now, before we graph this graph, let's take our basic graph, y is equal to the absolute value of x, and let's just do a quick list of our key points. We have a key point at negative 1, 1, at 0, 0, and at 1, 1. You could probably do more key points than that, but that's enough to kind of get the idea of our shape. Now, if we're doing g of x is the absolute value of x plus 2. So essentially we're taking all our y values and we're adding 2. So let's map these points. That would be negative 1, 3, 0, 2, and 1, 3. And let's sketch g of x first. So g of x has a point at 0, 2, 1, 3, negative 1, 3. And if we remember the shape of our absolute value, it's going to keep going this way and keep going this way. And let's sketch this one in. There's g of x. Now to do the inverse, we're going to take our key points and we're going to interchange our x and y values. So we will have a point at 3, negative 1, at 2, 0, and at 3, 1, and we can interchange some of the other points as well just by reading them off the graph and switching our x and y value. So we have a point at 2, 0, at 3, 1, and 3, negative 1. And for example, we also had a point at 2, 4. That becomes a point at 4, 2. And that's enough again to draw our graph. Now that we've got our original g of x and its inverse, the next thing we're going to sketch in is the line y equals x. I'm actually just going to sketch it in as a dashed line because we're actually going to use this line to kind of determine a relation between the two graphs. If you imagine folding the graph over the line y equals x, can you see how the graph and its inverse would be laying on top of each other? We can say that y equals x is like a mirror. For the graph and its inverse. So the idea is an inverse is actually another type of reflection. Specifically, it's a reflection across the line y equals x. So in the example we just did, you can see that the inverse graph is a reflection of the original graph along the line y equals x. That is always going to be the case for an inverse, and it might help you visualize your inverse. Usually the easiest way to graph is to start with some key points and change the x and y values. and kind of get yourself familiar with the idea of how to draw the original graph and the inverse just by practicing some of those. To kind of wrap this up, let's go over a little bit of notation. So we can ask different things about inverses, and each of them would really be asking you to do the same thing. So the first one says, sketch the graph of the inverse of y equals f of x. That's kind of the most straightforward. If you see this f with the -1, remember that is also notation for f inverse. That one is specifically used if the inverse is a function. The other way you may see this is you may see it with x equals f of y. Notice how the x and y have just switched places. That's another way of indicating that you want to switch the x and y value. The last way is you may just be asked to sketch a reflection over the line y equals x, because the inverse is the reflection across that line y equals x.